The second derivative test. Suppose f double ramp is continuous near C and A if f prime of C equal to 0 and f double ramp of C greater than 0, then f has a local minimum at C. B if f prime of C equal to 0 and f double ramp of C less than 0, then f has a local maximum at C. So now we want to graph the curve y equal x to the fourth minus 3x cubed with respect to the concavity, points of inflection, and local minima, and local maxima. Use the information to sketch the graph. Okay, so in order to do this, talking about the concavity, so we will find the second derivative, right? So first of all, let's assume that we have f of x equal x to the 4 minus 4x cubed. And we want to find the first derivative is we get 4x cubed minus 12x squared. For the future, I want to factor this out so that I can solve for this, right? Okay, and then f the parameter of x, I will get 12x squared minus 24x. And then I factor this out for the future, so I get x minus 2. Okay. So I want to use the second derivative in this box. I want to apply this box. This is what I mean, okay? So first of all, I find the first derivative at 0. So if f prime of x equal to 0, then I will get, so that means this equal to 0. For this equal to 0, I will get x have to be 0 or x have to be 3, okay? So I have two values, so that will be my C. My C is 0 and my C is 3. Then I will plug in the C into the f double ramp to find out that if f has a local minima or local maximum at that point. Okay, that's what they asked me to do in the question, right? So we plug in this into the f double ramp, okay? We plug both of them into f double ramp. So if we, f double ramp is this one, so we put in 0, then we will get 0. And if we put in the 3, we will get 3 times 12 is 36, times 1 is 36. I put in here, right? Okay. So now with the f double ramp equal to 0, it does not tell me anything. But with x equal to 3 is equal to 36, then I can see this now, right? Okay, so f prime of x equal to 0, and then we solve for x equal to 3. We plug in 3 into the f double ramp, we got 36. So this is exactly in part A. It say that. So what do we conclude? We conclude that f has a local minimum C is 3, okay? We want to find the point, then we will put that point x into the function f to find the output. You be careful, the answer is not 36 for if you put in the 3. This number 36 is just help you to check is its local maximum or minimum, to check positive or negative. But to find out the point on the graph, we will plug x value into the function f, okay? So we have 3 to the 4 minus 4, 3 squared. And it will give us negative 27. It's a local minimum. Okay, so let's talking about the zero. The zero does not tell us anything about local minimum or maximum. So I'm curious about the zero. So what I'm gonna do is I will put this on the number line for the f prime. Okay, and then I want to check this. So I'm gonna put the zero in here. So I put in the of f prime, the first one. If I put the negative number on f prime, what is my f prime? F prime is right here. Okay, so if I put negative number, I will get negative. And if I put positive number, I on the f prime, positive 1, then I still get negative. So this telling me that the tangent line will go this way, right? The tangent line, yeah, negative. So it does not tell me that much, any information that much. So I want to continue talking about the concavity, okay? So we recall that we have concavity concave up when f the param is positive, and when at f of the param less than 0, we will have concave up and we have concave down. So we remember that. So let's discuss that. So let's have the number line, and then let's put the two zero of the f the param, which is 0 and 2, x equal to 0, x equal to 0, and x equal to, right? So we're gonna put 0 and 2. And then we will plug in the point. So if we choose -1, it will give us positive. We are checking the f the param. So we plug in 12x parenthesis x minus 2, okay? So if we put in 1 right here, we will get negative. And if we put in 3, we will have positive. I am doing f the param, so 12x and x minus 3. So f the param positive from negative infinity to 0, and it's telling us this is concave up. Concave up is like this. And then this telling us is concave down, and this is telling us it's concave up. Okay, so the inflection point is the point that give us is the point between concave up and concave down. So this is the 2 point that give us the inflection point. So to find the point on the graph, we will plug these 2 point in the function f, okay? So in the function f, we have 0 to the 4th minus 4 times 0 cubed. Then we got 0, and we have, which is the point 0, 0, and we have f of 2 is 2 to the 4th minus 4 times 2 cubed, and we will get the answer is negative 16. So we have 3 points, basically 3 points for this graph. So we have 2 comma negative 16, and we have 3 comma negative 27. Okay, now we will plug them in. Okay, so we will have so we're gonna make this is like a -3, -6, -9, -12, negative 15, negative 18, negative 21, negative 24, negative 27. We have 3 here, 6 here, 9 here, and so on. And then the x is just normally like before, 1, 2, 3, 4, 5, right? Okay. So the first point is 0, 0. And we have the point 2, comma, negative 16. And we have the point is 3, comma, negative 27. So we have these 3 points. Okay, so between negative infinity to 0 is concave up. And between 0 to 2, we have concave down. So this is between 0 to 2, we have concave down. So we're going to draw like this, between 0 and between x equal to 0 and x equal to 2, concave down. And then more than 2 is concave up. So we're going to do like this, right? All right, so less than 2 is concave. Less than 2 is concave. Less than 0 is concave up. So we have like this. And then we have concave up after the 2. So we have because we have 3, comma, negative 27 is a local minimum. So local minimum means that this point, right here. So it's have to turn, right? So it's have to turn like this. Okay, so it's have to go like this. And if you want, you can find the x-intercept for the function f. Then we will find the exact answer. So for example, we can use the precalculus class. Okay, so we will take out the x cubed. Then we will get x minus 4. Then we have 0 is the intercept, x-intercept, and x equal to 4. So basically, we can draw like this, passing through the 4, okay? Yeah. And that's it, we finished the graph.